Hello friends. So in this section we are starting new unit, that is motion in two dimension or motion in a plane. Now to understand the concept of motion in a plane we need to understand the concept of vectors. So in this short video we would like to understand the concept of vector first, and then we will go for the remaining topics of motion in a plane. Okay, so let's see what do you mean by motion in a plane. So it's a plane, that means you have two dimensions. That means an object can move uh, in any of these two dimensions. Now, so far as the previous unit is concerned, motion in a straight line. For motion, we required or we studied about position, we studied about displacement, then velocity and acceleration. Right? And now so far as direction is concerned, so previously we had learned about only two dimensions, two directions, positive or negative. So if I consider this positive x-axis as my positive direction, then motion in this direction is negative. Or suppose up down movement is there, then you have these two, you can say, direction. So direction sense was very limited in the first unit, the previous unit, where we had studied motion in only a straight line. But now we are supposed to study motion in a plane. So let's see what does it mean. It means that suppose I have a conventional directions. Let's start with that. So these are the directions. This is west, east, north, and south. Right? Now suppose I have a body which is at present it is at its center. So suppose it moves from this point to this point with respect to time. That means its displacement is this much and it is in this direction. So how can we describe this? We can see that it is certain displacement in west. That means, and then you go north. So it is say west plus north. This is how I can explain. Suppose this body has moved from this point to this point, and the displacement is nothing but, I can say that this much in west, and this is this much in, once again, north. Suppose the body has moved over here, that means you can say, you can describe in this fashion that the body has moved this much units, you can say in east. This is east, sorry. So this is this much east, and then south. Right? So you can see that the displacement is having direction. Of course, velocity is also going to have direction because it is x2 minus x1. So what all is the direction? So velocity is going to have direction. Acceleration is also going to have direction. So it is necessary to understand how to indicate direction. For the physical quantities which we are going to study now, This is the concept which we are going to introduce in this lecture, and this is called the concept of vectors. So far we know our directions by common sense in our day-to-day life. We know north, south, east, west. So what all we would like to establish, we can establish in this fashion, right? But we would like to have a more systematic approach, and that approach is called the vector. So whenever we want to study motion in two dimension or motion in a plane, we need to understand the concept of direction first, because all the concept, there is concept of position, displacement, velocity, acceleration, what all we have learned in the unit motion of a straight line are valid in motion in a plane also. But the only thing is that in previous unit motion in a straight line, the direction was only positive or negative, that is in a particular direction or opposite to it. But here the direction can be anything in this fashion. You can see it can be in north south, it can be in east west in our conventional understanding, right? Now mathematically or in physics, how do we establish magnitude and directions? So let's try to understand the concept. That concept is called concept of vectors. So first we need to understand what are scalars and what are vectors. So a scalar quantity, a physical quantity, it has only magnitude. Example, say our weight. Say my weight is 75 kgs. So it has number only. A number is sufficient to represent, followed by the unit, that 75 kgs. Is it not? It does not require any direction. But suppose I would like to, you can say, establish force, or I would like to describe and explain the concept of force. Then I need to understand that how much is the magnitude and in which direction you are acting, right? There's a famous example that if you do not you can say indicate whether you are applying force in a particular direction or not, then instead of pushing an object, you will be pulling it, right? So instead of getting from one place to the second place, you will be sending it to the whole another place, right? So the concept of direction is now important. So in physics, wherever you require concept of direction also, the quantity is known as a vector. So a physical quantity which has magnitude and direction both is called a vector. Without any of this, that means without magnitude or without direction, it is meaningless. So you require both magnitude also and direction also. So this is something which is a very important concept. Now, what is a vector? So a vector is something which is having magnitude and direction. Now, how do we represent vector? So we represent vector by an arrow. So this is a vector A. We show it in this fashion, vector A. We show it by A cap arrow or A bar or A cap. Either of these three symbols are used to highlight that this is a vector quantity and it is having magnitude also with the you can say direction. So the length of the arrow indicates its magnitude. We call it mod of A with some scale. Right? Say suppose it's a say unit A is indicating force, then scale maybe say 1 centimeter is equal to 10 newtons or so, for example. So a vector is nothing but represented by an arrow which is having the length of arrow is equal to its magnitude, and direction is indicated by the direction of the arrow, right? So this is this when I'm indicating this, this is called tail of the arrow, and this is called head. And from tail to head, it is indicating the direction, right? So this is the concept of vector. A vector is a quantity which has magnitude as well as direction, right? So now let's try to understand the fundamentals of the vectors. So suppose I have two vectors A and vector B. I would like to find out whether they are equal or not. So this vector A is equal to vector B only if magnitude is equal and direction is same. And direction and magnitude both are equal, then only I can say that these two vectors are equal. Suppose this is in this direction A and this is also in the same direction. So this vector A and vector B are equal vectors. Magnitude also same, direction also same. Suppose they are in opposite direction. That indicates that A is equal to minus B, or the magnitude of two vectors are same, but direction is opposite. So such vectors are called opposite vectors. So these two vectors are, you can say, these are equal vectors or parallel vectors. These are opposite vectors. Okay, let's go one step further. Now, how to add two vectors? So I have two vectors A and B. At present, I am talking graphically only. How to add two vectors, right? Suppose I want to find out what is A plus B. So the concept is very simple. Suppose this is vector A and this is vector B, right? So what you are supposed to do to find A plus B, draw a vector A wherever its, you can say, head is finishing, that is the head of the arrow A. Draw a vector B which is parallel to and starting from the head of the vector A. So this vector B, they are same because they are parallel vectors B and B. So I am drawing wherever the vector A is finishing, from that I am starting the vector B. I am drawing the vector this which is parallel to B, and the magnitude or length of the arrow is equal to B. Now the starting point of A and finishing point of B, if I join, then this is going to give me the resultant vector or addition of vector A plus B. The other way to represent it, that you can form a parallelogram in this fashion. This is vector B and this is vector A, right? So parallel vectors I have drawn. So it is going to form a parallelogram, and the diagonal of this is going to give me the A plus B vector. So to find A plus B, I have to draw vector A first, wherever its head is there. From that, I have to start on the vector B, that is tail of the B vector is meeting at the point where head of the A lies. I am drawing vector B parallel to the original vector B. starting point, that is tail of the A and head of the B, if I join by another vector, new vector, that vector is called A plus B, right? So this is how you can graphically add two vectors. How to find A minus B? So A minus B in vector is nothing but it is A plus minus B. So just you have to add the opposite vector. So if B is over here, you can see, then this is going to be the minus B vector. We already know that opposite vector is having equal length or equal magnitude, but direction is opposite to it. So how to find A minus B? You can see, draw the vector A first over here, which is having length equal to A and direction also in the same direction of A. And now draw vector minus B from here. So somewhere over here, this is minus B vector, which is parallel to minus B and length equal to the minus B vector. So join this point, that is tail of A and head of the B. So you are going to get this resultant is nothing but A minus B, right? So A minus B is nothing but actually A plus minus B, right? So what we have understood so far, in motion of a plane, we need to understand the direction of motion also. So because displacement, velocity, acceleration, all will be in a particular direction. So we need to understand the direction, and direction can be indicated only if the quantity is a vector quantity. So we are trying to understand what are vectors. So we have understood that a physical quantity, when it is having magnitude as well as direction, then it is called a vector. What we have learned so far, that a vector is represented by an arrow which is having a certain length, which is indicating its magnitude to some scale, and the direction is indicating the direction in which that physical quantity is acting. The examples of vector quantities are force, velocity, acceleration. These are all quantities which are having magnitude as well as direction also. There are some quantities like weight of our weight, which is having no direction. It is having only a number. Such quantities are called scalar quantities, right? We have seen what are how to compare two vectors. That is what are equal vectors, what are opposite vectors. We have seen how to add two vectors and subtract two vectors. Now next concept is how to find you can say multiplication by a scalar. Suppose the vector is A and I want to find out how much is 10 times A. So what do you mean by 10 times A? So if suppose this is vector A, then 10 times A will be having magnitude 10 times and direction same as, right? So it is nothing but 10 into mod of A and then direction in the same direction, right? So now to avoid this confusion, now what do we use? We use concept of a unit vector. A unit vector is a vector having magnitude equal to 1 and direction indicating it is in a particular direction, right? Suppose this is vector, then I can say this is n cap is a, you can say n cap is having direction in the same direction as equal to the vector A, but it is having magnitude. So magnitude of n cap over here is 1 and it is nothing but unit vector of A, right? So here I can say it is 10 times magnitude of A into n cap. So I'm indicating magnitude also and direction also. So when I multiply any vector by say a scalar, say 2 times B, it is nothing but 2 times magnitude of B and vector will be in the same direction. You can say n cap, where n cap is unit vector in the direction of B. A unit vector is one which is having magnitude equal to 1. Okay, so that's the concept of multiplication by a scalar. Now, how to represent? See, this is how we are doing at present. In you can say graphically we are handling everything. But suppose I want to mathematically handle all these vectors. So all the time I cannot take a scale, draw a vector, then add and subtract graphically. That's a very cumbersome and slow process. So mathematically will be we'll be in need of frequent addition, multiplication, division, subtraction of the vector quantities. So how to handle that? So for that the concept of the coordinate geometry comes to our help, right? So it is very easy to establish. I'll have a concept of a, you can say it is also known as a rectangular coordinate system. So I'll introduce the concept in this fashion. Suppose this vector is there. This is vector A. So this vector can be shown as a sum of two vectors. See, this is vector, you can say A1. This is vector A2. So A1 is in certain direction, A2 is in certain direction, but my vector A is nothing but A1 plus A2. Now suppose A1 is along x dimension and A2 is along y dimension. That means by standardizing, I can represent a vector A in a certain units in x dimension plus certain unit in y dimension. If you recall the first example which we discussed, that an object when it moved from this point to this point, we had said that it is moved this much distance in, you can say, east plus this much distance in north. And then by that ultimately we had established the concept that this is the direction of you can say the vector A, where this is the, you can say, origin and this is the final destination. Then we can say that displacement is in this particular direction. Now the same concept we can use in a rectangular or xy coordinate system. So let's say that these are our xy coordinates. So can I not represent this very easily? Suppose this is my vector A. Then I can find out component, say this is the component, this much is parallel to x-axis and this much is parallel to y-axis, is it not? Let me say this is AX and this is AY, right? So this is positive y-axis, this is minus x, this is plus x, and this is minus y. This is my origin. So this is how I can represent that now my A is nothing but AX plus AY. Now that is alright, but this x and y are fixed directions. So generally when I mathematically handle such vectors, it is easy that I represent AX as a certain magnitude and direction, right? So we'll have the concept of unit vector in x, y, z direction, and we'll go to the next slide. So what I'll do, I'll take unit vectors, say this is unit vector along x-axis I, this is, you can say, along y-axis say j, and this is along z-axis say k, where these are my x and z dimensions. So let me have a I, j and k. So I is a unit vector along x-axis, that means positive x-axis. J is unit vector along y-axis, and k is unit vector along z-axis, right? So at present we are describing motion in 2 dimension or motion in a plane only. So let me say a vector. How can I represent very easily? So this is 1 and 2 units in that direction, and this is, you can say, 1, 2 and 3 units in y dimension, right? So I am moving this much dimension in x, and this is this much in y. And so this is nothing but I can say 2 times I, and this is 3 times j. J is a vector, I is a vector, and the resultant is my vector, say A. So now mathematically I can represent that this A vector is nothing but 2I plus 3j, where I and j are having the magnitude 1 and direction specified, I along x-axis only and j along y-axis, right? So this is how we can represent the any physical quantity in 2 dimension using vectors, using the our rectangular coordinate system or Cartesian coordinate system, where I and j are unit vectors. So we have learned so far that whenever you want to study the motion in let's say plane or 2 dimension, you need to understand the concept of direction first. For that you require to understand what are vectors. We have seen that vectors are the quantities which are having magnitude as well as direction. Vectors are represented by arrow, which is having certain length equal to its magnitude to some scale, and the direction of arrowhead is pointing towards the direction. We have seen how to compare two vectors, how to find opposite vector, how to add two vectors, how to subtract two vectors. We've also seen how to represent it mathematically in 2 dimensions, right? So with this concept, we'll continue the concept of vectors. We'll solve some examples, and then we'll understand that how the concept of motion in a straight line can be extended to motion in a plane just by introducing the concept of direction or vectors in it, right? So that's all in this session. We'll continue with the same in our next class.